Hey guys, Mr. A here, and I'm going to show you in this video how to write an equation of your line of fit that we put on your plot the last time we were in class. It's really not a tedious process. We did part of the hard work already. All we have to do now, as we talked about at the very end of our last class, is we have to figure out the slope of our line and the y-intercept. Now, before I go on, I just want to make sure I let you guys know that I already on our Canvas page, I have given everybody's y-intercept they should use for their line. I got those using technology, a app that does scatter plots and does the line of best fit and gives me the y-intercept from that equation of that line. So I've listed those in Canvas, so make sure you use the right one for your class as you try to determine the equation of your line. So I'm going to show you how I do that. This is just some fake data I just pulled together here real fast. And as you know, I would put my trend line or my line of fit on my plot. So I'm going to pick two order pairs on my plot. The first one I'm going to pick is 0, 10. 0, 10 right here, because that's my y-intercept. And the other one I'm going to select is, if you can notice here, we talked about that your trend line, if it goes through one of your data points, you may use that as an ordered pair. So I'm going to use the one here at midnight, 12 a.m., and I'm going to use that as my other point here. So I'm going to use the points 12, 7 and 0, 10. Okay, and I'm going to go down to problem number 6, I believe. Yes, problem number 6. And we're going to use these 2 points, 0, 10, and 12, 7, to find the slope. So we're going to find the slope first. Okay, so we'll do change in y over change in x. So we will do 10 minus 7, because those are the y coordinates. 0 minus 12, because those are the x coordinates subtracted in the same order. So I'll have a 3 on the top, a negative 12 on the bottom. That reduces to negative 1/4 for my slope. Okay, negative 1/4. Perfect. So in order to get the equation of the line, I just now need to find my y-intercept from Canvas. My y-intercept for my graph up here is the point 0, 10. Remember, I found that point on the y-axis. So that's my y-intercept. So I have my m value, that's negative 1/4. My v value is 0, 10. So then my equation, remember, equations are in the form y equals m times x plus b. So my equation then will be y equals negative 1/4 x plus 10. And that's all you have to do to get your equation of your line. We'll practice this again when we are able to meet again in person for class. But this should hopefully give you a chance to complete number 6 on your notes, which is part of your assignment. And then you can also then complete the assignment that will be on your next online day also. Those three scatter plot problems, right? To write the equation of the trend line and then use it to make predictions. I'm going to show you now how to complete number 7, and then we'll also do number 8 together. And then you can use number 8 together. After we do number 8, and you can use that process to complete problem number 9, okay? So number 7, we need to interpret our slope and our y-intercept. So remember, for slope, it's negative 1/4. Remember, the top number again is our change in y, and according to our y-axis, that's hours of sleep. Okay, and the bottom hour is time to bed. And remember, we talked about in class that it's best to reference this since 12 noon. So one way to interpret the slope is to say that a person loses, rewrite that, 1 hour of sleep for every 4 hours since noon, they wait to go to bed. Okay? And then for the y-intercept, then the interpretation would be a person who goes to bed at 12 noon, which was x equals 0, should get about 10 hours of sleep. Okay? So that's how you can complete those parts, problem 6 and 7. And then we're going to take our equation right here. I'm going to copy it actually. So copy it here. We're going to bring it into our problem on number 8 right here. And we'll go from there. Okay? So it says, use the equation from item 6 to predict the number of hours of sleep a person would receive if they went to bed at 11:30 p.m. Okay, well, the very first thing we have to figure out here is that, well, what value for x do I plug in for 11:30 p.m.? Well, we talked about in class that we're doing this based upon hours since 12 noon. So 11:30 p.m. is 11 and a half hours since noon. So we're going to do this for x equals 11.5. X equals 11.5. Push that to blue here just a second. So my equation becomes y equals negative 1/4 times 11.5 plus 10. So y equals negative 11.5 over 4. Let's multiply straight across here and add 10. Here's a little reference too, just so we have it here, okay? And let's move this over here too. So then I can explain the follow-up question here in just a second. I'm going to go to the calculator now. And we'll put this in our calculator. So we're going to put fraction. So negative 11.5 over 4. And we're going to add 10. And that becomes 7.125 hours of sleep. Okay? So there's my final answer for this one. Just going to clean that up a little bit here. Okay. Now, the follow-up question says, is this an example of interpolation or extrapolation? So let's take a look up here. I put those definitions up here right above problem number 8. So predictions included within a data set are examples of interpolation. So since 11:30 p.m. is a value within our data set, is because it's right there in the data set, right here, there's 11:30 p.m. Okay, this is an example of interpolation. Now, if the value is beyond the data set, so predictions that are beyond the data set, these are examples of extrapolation. So a value like 1 p.m. or 7 a.m. or something like that would be an example of extrapolation. So let's go ahead and answer this follow-up question, and then you can use this information to then repeat the process and complete problem number 9, okay? So since 11:30 p.m. is a value in the data set, This is an eLearning example of interpolation. Interpolation, again, is just a big fancy word that just means that the value that you are predicting the number of hours of sleep for in this case is within the data set. So according to our scatter plot, our line of best fit, a person who goes to bed at 11:30 p.m. should get approximately 7.125 hours of sleep, or 7.5 hours of sleep. Okay, so you can use this information to complete problem number 9, and then you can carry this over to complete problems 4, 5, and 6 on your assignment. If you have any questions, we'll address those on Thursday, hopefully. And you can also send me an email, and I will try to get with you as soon as I can. So I hope you enjoy your day and can get your notes caught up, and look forward to seeing you soon. Take care now.